guys ran a weight versus mass graph, in which case you said you could manipulate the mass by adding masses to the hanger. We said we'd measure that in kilograms and measure the corresponding weight. And while we normally measure weight in pounds, all of the scales had newtons on it, so we used a capital printed N for that. Below that, we only filled in digits. So when the mass added to the scale was 0, the weight was 0. When we added just the hanger, which was 0.050 kilograms or 50 grams, most people ended up with weights of about 0.5 newtons and so on. From that, you're expected to build a weight versus mass graph that should have a title and should have units for each of the axes and points plotted and find the slope. For an example today, I'm going to make a graph that's not this. I'm going to say as humans' ages increase, what happens to their weights at a close age. So I'm going to make up this fake graph in Google Sheets just to show you how to use the parts. Well, the first thing you need to do is go up to your, just go up to Google and just go ahead and click the option that gives you all these Google apps and go ahead and click on Sheets. And from Sheets, you can hit the plus sign and it'll open up a spreadsheet for you. And in this spreadsheet, I've already gone ahead and put in my data column. So in the first column over here, I put age as my independent variable and weights of the babies as my dependent variable. And now I'm just going to fill in values down below that. So at age 0, when you're born, about 8 pounds, and human beings at 6 might weigh around 60. By the way, these are totally made up values. They're not based on any scientific research. I just threw in a bunch of numbers. So how do we use this to then build the kind of graph that we're looking for? I'm going to go ahead and drop this back down to 100% so it's not expanded anymore. And what we want to do is we want to insert a graph at this time. So if we go up here to insert, it doesn't have an option to insert a graph, but Sheets uses the term chart instead of graph, which is incorrect, but that's what they use, so that's what we have to select. And sure enough, there we go. So I'm going to go ahead and expand this over here. I'm going to scooch the graph so we can see the data table as well. And what do you see here? We have a title of weight versus age, which is the y-axis versus the x-axis. Notice that the y-axis has the abbreviation for the variable weight as well as pounds. And down here we have the word age and the abbreviation for years. And we've got these data points here. Now, we currently have scatter chart selected. If you have something that is a line or a bar graph or something else that looks like this, go ahead and find this scatter chart instead. Once you've done that, we want to try to get the graph to find a slope. So we'll have to find a best fit line. So go to the right-hand column over here for customize. By the way, if this doesn't show up, all you have to do is double click on your graph. So if I close this, I can just double click on the graph right here and that'll show up again. The right-hand column says customize. I'm going to click on customize, and then I'm going to go down to the third one here that says series. And we're going to open up where it says series. Scrolling down through there, down below where it says format data point, there are 3 choices: error bars, data labels, and trend line. Trend line is similar to a best fit line, so let's go ahead and select that. And sure enough, we've got a best fit line on there. And then 3 lines below that, there's this thing that says label, right? Inside that, it says use equation. That's going to give us an equation for the line we have on the graph. So click use equation, and sure enough, we have this up here. Now, I'm not sure why this is showing up here. When I looked at this before, this would have said weight, because that's the name of the y-axis, is equal to, it gives you the values for the slope. But notice there's no units. So we should record 8.27 and whatever the units are over here, it's rise over run. So this would be pounds per year times what's the name of the x-axis. You'd have to put in age plus whatever the y-intercept is. 10.1, does that look like the y-intercept? That looks like it, right? So 10.1, and because it's the y-intercept, we'd have to associate pounds with that. So 10.1 pounds. What would 10.1 pounds tell us? Well, that would mean that following this basic trend, that perhaps I had guessed wrong, and that the average weight of a newborn baby is 10 pounds, which I think that might be a little heavy, but that's based off my false information. but 10.1 pounds was what we'd have there. So when you do your mathematical analysis, you're going to have to make sure that your y is the name of the y-axis. Your value in units of the slope should be correct, but you'll have to, the value is correct, you'll have to get the units from the y and x-axis. Make sure you multiply it by x, which is the name of the x-axis, the variable on the x-axis, plus whatever your y-intercept is with units. I do encourage you to go back and look at one of our previous mathematical analysis to run out the full 7 to 10 steps to the mathematical analysis. I think the Wheel and Axle Lab, the fake wheel and axle stuff back in early November is probably the best place to find that. And also remember to look at the reading on side 3 of this packet as well. I hope that helps.